Hello, my dear students. So, welcome back to another session of Maths for All. In this video, we are going to discuss about different graphs of inverse trigonometric functions. As I told in the last session, it is inverse trigonometric function part 1. So, in the part 1, we discussed about the graphs of sin inverse of sin x and the cos inverse of cos x, like that, and some properties. So, let us continue. So in this video, we are going to discuss the graphs of tan inverse of tan x, cot inverse of cot x, secant inverse of secant x, cosecant inverse of cosecant x, and along with some more properties of inverse trigonometric functions. Don't miss the video. Watch the video completely. So next graph of tan inverse of tan x. Tan inverse of tan x. So how do we draw the graph of tan inverse of tan x? So let us say y is equal to tan inverse of tan x. Y is equal to tan inverse of tan x. Y is equal to tan inverse of tan x. So from this tan y is equals to tan x. For all y belongs to open interval of minus pi by 2 comma plus pi by 2. Open interval of minus pi by 2 comma plus pi by 2. Acha. So now it is of the form tan y is equals to tan x. What is the general solution of tan y equals to tan x? General solution of tan y is equal to tan x is y is equal to n pi plus x for all n belongs to z. Y is equal to n pi plus x for all n belongs to z. So if you substitute different values for n, so what will happen? Let us see. If n equals to 0, then y equal to x. This is the one line. If n equal to 1, that is y equal to pi plus x. If n equal to 1, that is pi plus x. If n equal to minus 1, that is y equal to minus pi plus x. Y equal to minus pi plus x. If n equal to 2, that is y equal to 2 pi plus x. If n equal to minus 2, y equal to minus 2 pi plus x, and so on, like this. We can substitute so many values for n. We will get so many straight lines like this. So now let us draw the graph. A simple graph. So 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, this is 5 pi by 2, this is 3 pi, and so on. Because the domain of tan inverse x is minus infinity to plus, so the domain of tan inverse x is minus infinity to plus infinity, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. You can extend up to minus 5 pi by 2, minus 3 pi. And the value of tan inverse x, the graph of tan inverse x always lies in between minus pi by 2 to plus pi by 2. Acha. The graph of tan inverse x lies in between minus pi by 2 to plus pi by 2. Okay. The graph of tan inverse x is always lies in between minus pi by 2 to plus pi by 2. Acha. Now I am going to draw the graph of tan inverse of tan x. The principal domain of tan x is minus pi by 2 to plus pi by 2. So if the value of x lies in between minus pi by 2 to plus pi by 2, then tan inverse of tan x is equal to x. That is a basic property, very first property of tan inverse of tan x. Tan inverse of tan x is equal to x for all x belongs to minus pi by 2 comma plus pi by 2. So whenever x value lies in between minus pi by 2 to plus pi by 2, the graph of y equal to tan inverse of tan x is y equal to x. Now this y equal to x is a straight line passing through origin. So in between minus pi by 2 to plus pi by 2, the graph of tan inverse x is like this. It passing through origin and it should lie between minus pi by 2 to plus pi by 2. Acha. Now let us see the second line. How it look like? Y is equal to pi plus x. Y is equal to pi plus x. Y is equal to pi plus x. For your convenience, I am going to write like this: minus x plus y equal to pi. Acha. Minus x plus y equal to pi. Acha. So this straight line intersect the x-axis at minus pi and y-axis at plus pi. That straight line intersect the x-axis at minus pi and y-axis at plus pi. The straight line intersect the x-axis at minus pi and y-axis at plus pi. So if you take the second interval like this, minus pi by 2 to minus 3 pi by 2. So that straight line minus x plus y equal to pi intersect the x-axis at minus pi and y-axis at plus pi. So the straight line goes like this. So this is the second reason. What is the equation of this line? Y is equal to pi plus x. 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 Right. So you'll see one more line. So this one, list this one. Y equal to minus pi plus x. Y is equal to minus pi plus x. Y is equal to minus pi plus x. Acha. So take this minus pi to this side, so that x minus y is equal to pi. This is the line. X minus y is equal to pi. Acha. This straight line intersect the x-axis at pi and y-axis at minus pi. This straight line intersect the x-axis at pi and y-axis at minus pi, x-axis at pi, y-axis at minus. This side goes like this, and now this is the interval. Here is the interval pi by 2 to 3 pi by 2. So in this region, the line intersect the x-axis at plus pi and y-axis at minus pi. The straight line goes like this. I think you may got an idea. So here the function is not defined. Minus pi by 2 to pi at odd multiples of pi by 2, tan is not defined. At odd multiples of pi by 2, tan is not defined. Right. So in the next region, the next region is 3 pi by 2 to 5 by 2. The line should be like this. The line should be like this. In the next region, the line should be like this. In this region, the line should be like this. No doubt about it. No doubt about it. No doubt about it. So this is the graph of tan x, tan inverse of tan x. This is the graph of tan inverse of tan x. Right. What is the equation of this line? This is y equal to x, right? And now this line intersect the x-axis at pi and y-axis at minus pi, x minus y equal to pi, so that y is equal to x minus pi. So y is equal to x minus pi. So this straight line intersect the x-axis at 2 pi and y-axis at minus 2 pi. So x minus y equal to 2 pi. This is y is equal to x minus 2 pi. Y is equal to x minus 2 pi. I think you got an idea. Y equal to x minus 0. Y equal to x minus pi. Y equal to x minus 2 pi. Y equal to x minus 3 pi. Y equal to x minus 4 pi. Y equal to x minus 5 pi, like this. Very simple. Very simple. This is y equal to pi plus x. Now let us see this one. What about this one? The straight line intersect the x-axis at minus 2 pi, y-axis at plus 2 pi. So minus x plus y is equal to 2 pi. So y equal to 2 pi plus x. This is y equal to 2 pi plus x. Y equal to 2 pi plus x. And next one, y equal to 3 pi plus x. Next one, y equal to 4 pi plus x. Very simple, very simple, very simple. This is the graph of tan inverse of tan x. This is the graph of tan inverse of tan x. Okay. So now I'll ask a small question to you. I'll ask a very small question to you. What is the value of tan inverse of tan 5 pi by 6? You may ask a question like this. What is the value of tan inverse of tan 5 pi by 6? 5 pi by 6 means 150 degrees. 150 degrees. 150 degrees lies in this region. Right? 150 degrees lies in this region. So in this region, y equal to x minus pi. So this is y. So y equal to x minus pi. X means 5 pi by 6 minus pi. Right? Achha. So y is equal to minus pi by 6 is the answer for this question. Tan inverse of tan 5 pi by 6 is minus pi by 6. Suppose he may ask the question like this. What is the value of tan inverse of tan 6 radians or tan 5 radians, right? Tan 5 radians. Tan inverse of tan 5. You may ask the question like this. Only tan inverse of tan 5 may gives. Tan inverse of tan 5. 5 means 5 radians. 5 means 5 radians. As I told in the last class, 5 radians is nothing but 285 degrees. 5 radians is nothing but 285 degrees. 285 degrees lies in this region. After 270, before 450. So this region, in this region, 5 radians lies. So what is the answer for this question? Y equal to x minus 2 pi. Here x means 5 minus 2 pi. So tan inverse of tan 5 is nothing but 5 minus 2 pi. Tan inverse of tan 2 pi. Tan inverse of tan 5 is 5 minus 2 pi. That is the use of the graph. Very, very important. This is the graph of tan inverse of tan x. So tan inverse of tan x is equal to x in between minus pi by 2 to plus pi by 2. Tan inverse of tan x equal to x minus pi in between pi by 2 to 3 pi by 2. Tan inverse of tan x equal to y x minus 2 pi in between 3 pi by 2 to 5 pi by 2, and so on. Clear? Acha? Okay. So by observing the tan inverse of tan graph, you can draw the graph of cot inverse of cot x. You can draw the graph of cot inverse of cot x. Graph of cot inverse of cot x. Graph of cot inverse of cot x. Acha. Just now we derive the graph of tan inverse of tan x. By using that, you can draw the graph of cot inverse of cot x very easily if you remember the principal domain of cot. Acha. So 0, pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi, so on. This is minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, minus 5 pi by 2, minus 3 pi, and so on. And so on. So the graph of cot inverse x lies in between 0 to pi. The graph of cot inverse x lies in between 0 to pi. So the graph of cot inverse x lies in between 0 to pi. The graph of sin inverse x lies in between minus pi by 2 to plus pi by 2. The graph of cos inverse x lies in between 0 to pi. The graph of tan inverse x lies in between minus pi by 2 to plus pi by 2. The graph of cot inverse x lies in between 0 to pi. But what is the principal domain of cot? 0 to pi. Principal domain of cot 0 to pi. So first of all, you have to take this region 0 to pi. 0 to pi. In between 0 to pi, cot inverse of cot x is x. In between 0 to pi, cot inverse of cot x is x. So this is the line. This is the line. Y is equals to x. Y is equals to x. Right. So next interval, pi to 2 pi. Pi to 2 pi. Pi to 2 pi. So in this region, the graph of cot inverse of cot x is like this. Just now we observed the graph of tan inverse of tan x now a similar way. In the next region, 2 pi to 3 pi. So the graph of cot inverse of cot x is like this. In a reverse way, in minus pi to 0, the graph of cot inverse of cot x is like this. Here it's not defined, here it's not defined, 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 it's not defined here. And then next one, minus 2 pi to minus pi, minus 2 pi to minus pi. So the line like this. And then a minus 3 pi to minus 2 pi, the graph of cot inverse of cot x is like this. Right? Achha. So now, how do we write the equation of lines? So this line passing through horizon. Now what about this line? This line intersects the x-axis at pi, y-axis at minus pi. It goes like this. But it should lie between minus pi to 0 to pi. So this straight line intersects the x-axis at pi and y-axis at minus pi. So that's line x by pi minus y by pi is equal to 1. Achha. So x minus y equal to pi. So y equals to x minus pi. Equal to x minus pi. So this is the line y is equal to x minus pi. So this is the line y equal to x minus 2 pi. Y equal to x minus 2 pi. And here the line intersects the x-axis at minus pi. So x by minus pi and y-axis at plus pi. See there? So plus y by pi is equals to 1. So minus x plus y equals to pi. So y equal to x plus pi. So this is y equal to x plus pi. Similar way, this is y equal to x plus 2 pi. And this is y equal to x plus 3 pi. X plus 2 pi, x plus 2 pi, x plus pi, x minus pi, x minus 2 pi, and so on, like this. This is a simple graph of cot inverse of cot x. Like this, we can draw the graphs of sin inverse of sin x, cos inverse of cos x, tan inverse of tan x, and cot inverse of cot x. So secant inverse of secant x graph is similar to cos inverse of cos x, excluding the values of x is equals to 2n plus 1 into pi by 2. Odd multiples of pi by 2 have to exclude. Why? Because secant is not defined at odd multiples of pi by 2. Cosecant inverse of cosecant graph is similar to sin inverse of sin x, excluding the values of x is equals to n pi. Come again. Secant inverse of secant x graph is similar to cos inverse of cos x, excluding the values of x is equal to 2n plus 1 into pi by 2. Remember, cosecant inverse of cosecant x graph is similar to sin inverse of sin x, excluding the values of x is equal to n pi. X is equal to n pi. So these are the 6 important graphs in trigonometric function, inverse trigonometric functions. So next we are going to discuss the properties of inverse trigonometric functions. We have already discussed the two properties. Those are basic properties, property number 1 and property number 2. Property number 1 is sin inverse of sin x is equal to x for all x belongs to principal domain of minus pi by 2 to plus pi by 2. Cos inverse of cos x equal to x for all x belongs to 0 to pi, like this. Second property, sin of sin inverse x is equal to x for all x belongs to closed interval of minus 1 comma 1, like this. So now we are going to discuss about the third property, property number 3. Property number 3, that is negative property. Negative property, that is sin inverse of minus x is equal to minus sin inverse x for all x belongs to closed interval of minus 1 comma plus 1. Cos inverse of minus x is equal to pi minus cos inverse x, but not minus cos inverse x for all x belongs to closed interval of minus 1 comma plus 1. Very, very important properties, negative properties. Tan inverse of minus x is equal to minus tan inverse x for all x belongs to R. For all x belongs to R. Cot inverse of minus x is equal to pi minus cot inverse x. Pi minus cot inverse x for all x belongs to R again. Secant inverse of secant x. Secant inverse of secant x is equal to pi minus secant inverse x for all x belongs to minus infinity to minus 1 closed union 1 to infinity. And the sixth one is cosecant inverse of cosecant x. Cosecant inverse of cosecant x is equal to minus cosecant inverse x for all x belongs to minus infinity to minus 1 union 1 to infinity. This is a very, very important property. This is called negative property. Sin inverse of minus x, minus sin inverse x, cos inverse of minus x, pi minus cos inverse x. So proofs of these properties are very, very important. We will discuss one or two. How to derive these properties. Let us see. First one, sin inverse of minus x is equal to minus sin inverse x. See, let sin inverse of minus x is equals to theta. Sin inverse of minus x is equals to theta. For all minus 1 less than or equal to minus x less than or equal to 1. Sin inverse of minus x defines when this value lies in between minus 1 to plus 1 and this value lies in between minus pi by 2 to plus pi by 2. And minus pi by 2 less than or equal to theta less than or equal to pi by 2. Theta less than or equal to pi by 2. Achha. So if this theta lies in between minus pi by 2 to plus pi by 2, then I can take this sin inverse to that side. If theta lies in between minus pi by 2 to plus pi by 2, if this theta lies in between principal domain of sine, then only I can take this sin inverse to that side. Otherwise I can't. So minus x is equal to sine theta, because theta lies in between principal domain of sine. Theta lies between principal domain of sine. Very, very important. So from this I can write x is equal to minus sine theta. X is equal to minus sine theta. Achha. So x is equal to sine of minus theta. X is equal to sine of minus theta, right? Achha. So now I can take this sine to this side, sine inverse. When I can take this sine to this side, when this x belongs to lies in between, this x belongs to closed interval of minus 1 comma plus 1, and this minus theta lies in between minus pi by 2 to plus pi by 2. So theta lies in between minus pi by 2 to plus pi by 2 is, what about minus theta? Just multiply with the negative sign. So minus pi by 2 less than or equal to minus theta less than or equal to plus pi. If theta lies in between minus pi by 2 to plus pi by 2, then minus theta is also lies in between minus pi by 2 to plus pi by 2. So that means this lies in the principal domain of sine. If x lies in between minus 1 to plus 1, then minus x is also lies in between plus 1 minus 1 to plus 1. So this x definitely lies in between -1 to +1. So I can take this side to this side. So sine inverse of x is equal to minus theta. So therefore multiply with minus sign, theta equal to minus sine inverse x. Theta is equal to minus sine inverse x. So theta equal to minus sine inverse x. Theta equal to minus sine inverse. What is theta? What is theta? Theta. So theta is sine inverse of minus x. So sine inverse of minus x is equal to minus sine inverse x. Sine inverse of minus x is equal to minus sine inverse x. So you can prove this property like this. Very simple, very simple. But if you take the second one, the second one is like this. What is the second one? Cos inverse of minus x is equal to pi minus cos inverse x. Cos inverse of minus x is equal to pi minus cos inverse x. For all x belongs to closed interval of -1 comma +1, cos inverse of minus x is equal to pi minus cos inverse x. For all x belongs to closed interval of -1 comma +1. Achha. So let cos inverse of minus x is equal to theta again. Cos inverse of minus x is equals to theta. So if x value lies in between -1 to +1, then minus x is also lies in between -1 to +1, where -1 less than or equal to minus x less than or equal to +1. But what about theta? Here the function is cos now, cos. So and 0 less than or equal to theta less than or equal to pi, because that is the principal domain of cos. Achha. Whenever this theta lies in between 0 to pi, so definitely I can take this cos inverse to that side. So minus x is equal to cos theta. Minus x is equal to cos theta. So x is equal to minus cos theta. X is equal to minus cos theta. So x is equal to cos of minus theta. Cos of minus theta minus cos theta. No. Is cos of minus theta equal to minus cos theta? No. Then how do you write minus cos theta? We can't write cos of minus cos theta as cos of minus theta like sign. Then how do you write? Cos of minus cos theta can be written as cos of pi minus theta. Cos of pi minus theta. Pi minus theta belongs to second quadrant. In second quadrant, cos negative. So cos of pi minus theta is minus cos theta. So this minus cos theta can be written as cos of pi minus theta. So now take this cos to this side. When I can take this cos to this side, I can take this cos to this side when this x should lies in between -1 to +1, and this angle should lies in between 0 to pi. This angle should lies in between 0 to pi. Is pi minus theta lies in between 0 to pi? Who knows? Who knows? I know about theta. I don't know about pi minus theta. Let us calculate. From this, you have to calculate where pi minus theta should lie. So 0 less than or equal to theta less than or equal to pi. Multiply with minus sign. So if you multiply with minus sign, this is minus pi less than or equal to minus theta less than or equal to minus 0. Oh, don't write minus 0. So minus pi less than or equal to minus theta less than or equal to 0. Now I want pi minus theta. I know about pi minus theta. No? So if you want pi minus theta, add pi to the entire inequality. So pi minus pi 0 less than or equal to pi minus theta less than or equals to pi. If you add pi to the entire inequality, so this becomes 0 less than or equal to pi minus theta less than or equal to pi. See, observe, pi minus theta. Where it lies? Pi minus theta should lie between 0 to pi. Here pi minus theta lies in between 0 to pi. Is 0 to pi a principal domain of cos? Definitely. So definitely I can take cos to this side now. So cos inverse of x is equal to pi minus theta. Cos inverse of x is equal to pi minus theta. Now take this minus theta to side and take this cos inverse x to that side. So theta is equal to pi minus cos inverse of x. Theta is equal to pi minus cos inverse of x. But what is theta? Here it is. What is theta? Cos inverse of minus x. Cos inverse of minus x is equal to pi minus of cos inverse x. Cos inverse of minus x is equal to pi minus of cos inverse x, like this. Like this, we can prove the remaining properties also. Tan inverse of minus x, we can prove. Cot inverse of minus x, you can prove. So try to prove the remaining results. Then you can improve your subject levels. Okay, right. The next property, property number 4, reciprocal property. Property number 4. That is sine inverse of 1 by x. Sine inverse of 1 by x is equal to cosecant inverse of x. For all x belongs to minus infinity to minus 1 union 1 to infinity. Sine inverse of 1 by x is equal to cosecant inverse of 1 by cosecant inverse of x. So when 1 by x belongs to minus infinity to minus 1 union 1 to infinity, then x belongs to minus 1 to plus 1. Reverse way. Cos inverse of 1 by x is equal to secant inverse of x. Secant inverse of x. For all x belongs to again minus infinity to minus 1 union 1 to infinity. 1 to infinity. And now third one is important. Tan inverse of 1 by x. Tan inverse of 1 by x is equals to cot inverse x. Cot inverse x if x greater than 0. If x greater than 0. Minus pi plus cot inverse x. Minus pi plus cot inverse x if x less than 0. Very, very important properties are reciprocal properties. Reciprocal properties these are. Sin inverse of 1 by x is equal to cosecant inverse of x. Cos inverse of 1 by x equal to secant inverse of x. Tan inverse of 1 by x is equal to cot inverse x if x greater than 0. Minus pi plus cot inverse x if x less than 0. Achha. Right. Let us see how do we prove these results. So I will prove first one and this one. Right. What is the first one? Sin inverse of x. Sin inverse of 1 by x is equal to cosecant inverse of x. For all x belongs to minus infinity to minus 1 union 1 to infinity. So let us prove. As usual, let cosecant inverse of x is equals to theta. Cosecant inverse of x is equals to theta. From this, x is equals to cosec theta. X is equal to cosec theta. If I write like that, here definitely theta should lie between theta belongs to closed interval of minus pi by 2 comma plus pi by 2 except 0. Except 0. Achha. So now take the reciprocal. So 1 by x is equal to 1 by x is equals to 1 by x is equals to sin theta. 1 by x is equals to sin theta. Achha. 1 by cosecant theta sin theta na. So this here theta, here also this theta. So theta lies in between minus pi by 2 to plus pi by 2 no. So is it the principal domain? Yes, definitely this is a principal domain of sine, no doubt about it. So from this theta is equals to sine inverse of 1 by x. Theta is equals to sine inverse of 1 by x. But what is theta? What is theta? So cosecant inverse of x. Cosecant inverse of x is equal to sine inverse of 1 by x. We can prove this result in a simple manner. It's a very easy thing. Cosecant inverse of x is equal to sine inverse of 1 by x. I can prove secant inverse of x is equal to cos inverse of 1 by x like this. Simple thing. But the next one is somewhat different. Tan inverse of 1 by x. Tan inverse of 1 by x is equal to cot inverse of x is equal to cot inverse of x if x greater than 0 minus pi plus cot inverse x minus pi plus cot inverse x if x less than 0. If x less than 0. So very important. Let us see proof. So let, as usual, cot inverse of x is equals to theta. Cot inverse of x is equals to theta. Acha. From this x is equal to cot theta. X is equals to cot theta. When I can write x is equals to cos theta for all theta belongs to 0 comma pi, because that is the principal domain of cot. That is the principal domain of cot. Very, very important. So, theta is very important. Theta plays a major role in inverse trigonometric function. So theta belongs to 0 comma pi. Theta lies in between 0 to pi. Acha. So now take the reciprocal. So 1 by x is equals to tan theta, isn't it? 1 by x is equals to tan theta. 1 by x is equals to tan theta. Acha. So now just apply tan inverse on both sides. So tan inverse of 1 by x is equals to tan inverse of tan theta. Tan inverse of 1 by x is equals to tan inverse of 1 by x is equals to tan inverse of tan theta. Clear? Right? So in this video only, just now we discussed about the graphs of tan inverse x, right? So the graph of tan inverse of tan x is lies in between minus pi by 2 to plus pi by 2. This is 0. This is minus pi by 2. This is 0. This is pi by 2. This is 3 pi by 2. In between 3 pi by 2 to pi, this is pi. Okay. So tan inverse of tan x graph is like this. Okay. So now, which region you want here? 0 to pi. So in which region here you want here? 0 to pi, 0 to pi, 0 to pi. Right. Acha. So in the entire 0 to pi region, is the graph of tan inverse x same line? Tan inverse of tan x same line? No. In this 0 to pi by 2, the graph of tan inverse of tan x like this. In this pi by 2 to pi, in this pi by 2 to pi, the graph of tan inverse x is like this. So in this 0 to pi by 2, the graph of tan inverse x is y equals to x. And the graph of tan inverse x is y equal to x. In this pi by 2 to pi, in this pi by 2 to pi, here the line intersect the x-axis at pi and y-axis at minus pi. So x by pi minus y by pi equal to 1. X minus y equal to pi. X minus y equal to pi. X minus y equal to pi. Y equal to x minus pi. Y equal to x minus pi. Acha. So this is y equal to minus pi plus x. Y equal to minus pi plus x. Understood or not? Acha. So therefore, tan inverse of 1 by x is equals to tan inverse of tan theta is equals to theta. Tan inverse of tan theta is equals to theta if 0 less than theta less than pi by 2. Am I correct? Tan inverse of tan theta is equals to theta if 0 less than theta less than pi by 2. Clear? No doubt about it. And in between pi by 2 to pi, tan inverse of tan theta is minus pi plus theta if pi by 2 less than theta less than pi. If pi by 2 less than theta less than pi. No doubt about it. Achha. So therefore, tan inverse of 1 by x is equals to what is theta? Cot inverse x. If 0 less than theta means cot inverse x. So 0 to pi by 2 means it is positive. So an x greater than 0. So minus pi plus theta cot inverse x. Minus pi plus theta means cot inverse x, right? Minus pi plus cot inverse x. If pi by 2 less than theta less than second quadrant. So x in second quadrant means theta less than 0. X less than 0. So therefore, tan inverse of 1 by x is equals to cot inverse x if x greater than 0. Tan inverse of 1 by x equal to minus pi plus cot inverse x if x less than 0. Very, very important property here. To prove this result, graph plays a major role. Without graph, it is very difficult to prove. Okay, so tan inverse of 1 by x equal to cot inverse x if x greater than 0. Tan inverse of 1 by x equal to minus pi plus theta, like this, minus pi plus cot inverse x if x less than 0. Like this, we can prove this property. Okay, this is a reciprocal property. Sin inverse of 1 by x equal to cosecant inverse x. Cos inverse of 1 by x equal to secant inverse of x. Tan inverse of 1 by x. There are two cases. Cot inverse x if x greater than 0. Minus pi plus cot inverse x if x less than 0. Okay. Very, very important. We'll go for the next property, that is also very important property, property number 5. That is first one, sin inverse x plus cos inverse x is equal to pi by 2. Sin inverse x plus cos inverse x is equal to pi by 2 for all x belongs to closed interval of -1 comma +1. Tan inverse x plus cot inverse x is equal to pi by 2 for all x belongs to R. For all x belongs to R. Secant inverse x plus cosecant inverse x is equals to pi by 2 for all x belongs to -infinity to -1 union 1 to infinity. Very important property. This is sin inverse x plus cos inverse x equal to pi by 2, tan inverse x plus cot inverse x equal to pi by 2, secant inverse x plus cosecant inverse x equal to pi by 2 for all x belongs to -infinity to -1 union 1 to infinity. X belongs to R, x belongs to -1 to +1. So let us see. I'll give the proof for one property. That's the sin inverse x plus cos inverse x equal to pi by 2. How do you prove? Let sin inverse x is equals to theta. Let sin inverse x is equals to theta. So from this, x is equals to sin theta. X is equals to sin theta. Achha. X is equals to sin theta. So when I can write like this, very, very important for each and everything, theta is very important. When I write like this, where minus pi by 2 less than or equals to theta less than or equal to plus pi. Minus pi by 2 less than or equal to theta less than or equal to plus pi by 2. Achha. So x is equals to sin theta can be written as cos pi by 2 minus theta. Sin theta can be written as cos pi by 2 minus theta. Yes, definitely. Now take this cos to this side. When I can take this cos to this side, definitely this angle, if this angle lies in between the principal domain of cos, if this angle lies in between 0 to pi, then only I can take this cos to this side, otherwise I can't. And of course, this x should lies in between -1 to +1. So here this if this x lies in between -1 to +1, automatically this x is also, there is no change in this x. But here the angle changes. The theta lies in between minus pi by 2 to plus pi. I know about theta, but I don't know about pi by 2 minus theta. Let us calculate. So multiply with the negative sign. So then minus pi by 2 less than or equal to minus theta less than or equal to plus pi by 2. I want pi by 2 minus theta. Add pi by 2 to the entire inequality. Add pi by 2. Add plus pi by 2. So plus pi by 2 minus pi by 2 0 less than or equal to pi by 2 minus theta less than or equal to pi by 2 plus pi. Pi by 2 plus pi by 2 is pi by pi. Sorry. So now see, pi by 2 minus theta lies in between 0 to pi na. But 0 to pi is the principal domain of cos. So definitely this angle lies in between the principal domain of cos. So that's, I can take this cos to this side. So cos inverse of x is equal to pi by 2 minus theta. Cos inverse of x is equal to pi by 2 minus theta. Now take this minus theta to this side. So this is theta plus cos inverse x is equals to pi by 2. Theta plus cos inverse x is equal to pi by 2. So here theta means sin inverse x. So sin inverse x plus cos inverse x is equal to pi by 2. For all x belongs to closed interval of -1 comma +1. So sin inverse x plus cos inverse x is equal to pi by 2 for all x belongs to closed interval of -1 comma +1. Right? So like this, we can derive each and every property of inverse trigonometric functions. Okay. So in the next video, so we are going to discuss some more properties along with some important problems. In the next video, we are going to discuss some problems also. Okay. So if you like my explanation, please do subscribe. So don't miss the videos. Okay. So we'll meet in the next video. Till then, bye-bye.